So let's take a look at this example. We want to make a 4-digit password, and we are allowed to use the numbers 0 through 9, but we're not allowed to have any repetition in our password. We want to know how many different passwords are we able to make. So let's think about this a little bit. So we know that we're making a 4-digit passcode. 4-digit passcode. And we want to know how many different ways can we make this 4-digit passcode. So if we're allowed to use the numbers 0 through 9, but they're not allowed to repeat, we have to ask ourselves, how many options do we have for the first number? Well, since we haven't used any numbers in the first number, we have 10 options. We can use any number from 0 to 9. Let's say, for example, we used a 5. So if we used a 5, now we can no longer use a 5 in any of these other positions, which means in my second position, how many options do I have? Well, I have 9. I can use any number but 5. So I have 9 options here. So now I've used 2 numbers. So for the next number, I can't use either of those 2. So I have 8 options. And then for the last one, I will have 7 options. So it descends by the number of options that we use here. So there's only 4 numbers. Now, what do we do with these numbers? Well, this is kind of like the multiplication property that tells us we have 10 choices, then we have 9 choices, 8 choices, and 7 choices. So that means we're going to multiply all of these numbers. So you're going to go and multiply all of these together. And when you do that, you end up with 5,040. So we have 5,040 different passwords that we could make if we were allowed to only use the numbers 0 through 9, and our numbers were not allowed to repeat. So there would be 5,040 possible 4-digit passwords. So what did we just make? This here is just called a permutation. So a permutation is an arrangement of numbers or letters in which the order matters, right? Because if you think about a password, if you plugged in, let's say that our password was 5379, right? It was just those numbers. This password is different than 3579. Just by changing the first 2 numbers, we have a new password. At least we should, right? If this and this was the same, that would cause a lot of problems. So this is called a permutation. And in our book, we denote the permutation like this. So this is a permutation of 10 objects, right? We had 10 options to start, and we're taking them 4 at a time. We're taking 4 objects for this password. So our book will say that this was a permutation of 10 objects taken 4 at a time. This is the notation that they use. You may have seen before this notation, 10p4. These mean the exact same thing. Our book just uses this notation. So this again was something called a permutation without repetition. And we see this notation here. So the definition of permutation, the way that we can actually calculate a permutation, is this formula here. So this is the permutation formula. So the permutation of n objects taken r at a time is equal to n factorial. So remember, this exclamation mark means factorial, divided by the quantity n minus r factorial. So you take the difference of these two. What does factorial mean? So just a quick reminder on what factorial means. So if you have something like 4 factorial, that means that you start at 4, the integer 4, and you multiply it by all of the integers until 1 in descending order. So 4 times 3 times 2 times 1. So this would end up being 12 times 2, which is 24, times 1 is 24. So that would be 4 factorial. 1 factorial by definition is just 1, and 0 factorial by definition is 1. So this is a permutation without repetition, and this is the formula that you use.